Hey class, in today's lesson we're going to talk about geometric series, which is found in section 9-5 of your book. Our objective is to define geometric series and find their sum. So it says in example 1, what is the sum of the finite geometric series? So we have, for the first example, 3 plus 6 plus 12 plus 24 plus all the way up to 3072. Okay. Well, I guess in order to be able to do this, we actually need to know what the formula is. So our formula that we will use to find the sum of finite geometric series is S sub n, which means the sum, is equal to a sub 1, which is the first value, times 1 minus r, that ratio, to the nth power, divided by 1 minus r. Okay, so we're going to apply this into our next formula. So we don't know in our first one what n is. In order to find S sub n, you definitely need n. And we don't know how many values there are. So in order to do that, we're going to need the very first formula that we were dealing with, which is a sub n is equal to a sub 1 times r to the n minus 1. Okay, so let's do that. A sub n is going to be 3072. That's our last value, is equal to the first value times the ratio. The ratio here is obviously being multiplied by 2, so 2 times, and we don't know what n is right now. N is just going to be n minus 1. Okay, so we're going to divide both of these by 3, and that's going to give us 1024 equal to 2 to the n minus 1 power. Okay, so to be honest, from here we've done log and stuff, right? So we could do log of 1024 is equal to log of 2 to the n minus 1. That would put the n minus 1 in front, so this would be log of 1024 is equal to, in parentheses, n minus 1 log of 2. Divide both sides by log 2, and then eventually we'll add 1 to that. Alright, so let's throw that into the calculator. Let's see. Log of 1024 divided by log of 2 will give us 10, and if we're going to add 1, then n will equal 11. So we have 11 as n. Now we're going to go back and apply to find the sum. Okay, so S sub n now is S sub 11 is equal to our first value, which is 3, times 1 minus the rate. Our rate is 2, right? Because it was times 2 every time. 2 to the 11th power over 1 minus 2. Okay, so if we keep going, that'll be 3 times 1 minus 2 to the 11th is 2048 over negative 1. That's still going to be 3 times negative 2047 divided by negative 1. So our answer is going to be, as a final answer, 6,141. Alright, now that's our answer for the first one. And again, we started from knowing what the question asked for, which was the sum formula, so we had that here. Okay, and then from that we said, well, how can we find S sub n if we don't know what n is? That formula clearly asked for n, and we didn't know what n was, so to be able to find n, we had to use our original first formula. Okay, we were able to substitute everything in, but then we had a problem once we had n minus 1, so we had to apply log. There's another way you can do it, just kind of using mental math, but log is the better form. So we applied log and then solved, and we found n, and then we used that n to substitute back into the sum formula. So I'm going to clear all of this and show you the next example. Alright, so that kind of also got rid of the first example. That wasn't what I meant to do, but that's okay. Alright, so for the second one, we will have, and again, let me write out the formulas. That's S sub n equal to a sub 1 times 1 minus r to the nth power over 1 minus r. And then the other one that we need to remember is a sub n equal to a sub 1 times r to the n minus 1. All right, so obviously we're going to have to start with the second one. So a sub n is 1 over 128 equal to the first value, which is 4. We don't know the rate. And actually, we do know the rate. I'm sorry. We do know the rate. That rate from 4 to 2 and then 2 to 1, we're obviously dividing by 2, so that's 1/2 to the, and now we don't know what n minus 1 is. So we're going to divide by 4, or in other words, multiply by 1/4. And that's going to give us 1 over 512 equal to 1/2 to the n minus 1. Again, we'll do log of both sides. So log of 1 over 512 is equal to log of 1/2 to the n minus 1. We'll apply the n minus 1 to the front of that one. So that would be log of 1 over 512 equal to n minus 1 log of 1/2. Now we're going to divide both sides by log of 1/2. And then we're going to throw this in our calculator. So log of 1 over 512 divided by log of 1/2 is actually going to give us 9. But again, we still need to add that 1. So n is going to equal 10. Okay, so now that we have n equal to 10, we can apply it in our new formula. So s sub n is going to be s sub 10 equal to a sub 1 is 4 times 1 minus the rate is 2, or excuse me, 1/2, to the nth power is going to be 10, divided by 1 minus 1/2. All right, so for the numerator, that's really going to be 4 times, let's see, 1/2 to the 10th, that's really, that'd be 1 minus 1 over 1024 divided by, that's 0.5 or 1/2. I'm going to change all these to a decimal in just a moment. So 1 minus 1,024th. It's going to be about 0.999, and then we're going to multiply that by 4 and then divide that by 1/2. And so our answer is going to be about, it's really 7.99, but we'll go ahead and round it up to 8. So about 8. And like I mentioned, it's really about 7.992. Okay? All right, so that's the first example. After this, all we have is a try, so let's go ahead and do the try. Okay, again, we have two equations, so we need to write the first one. S sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r, and a sub n equal to a sub 1 times r to the n minus 1. All right, if we apply the first one, we're going to need to find what n is first. So that would be negative 15 equal to, sorry. A sub n is our last value. I apologize. This is a sub n. So that's 480 equal to negative 15 times r, which is times negative 2, to the n minus 1, and we don't know what n minus 1 is. Okay, if we divide by negative 15 first, 480 divided by negative 15 is going to give us negative 32. Okay, again, we need to apply log on both sides, and then so this would be log of negative 32 equal to log of negative 2 to the n minus 1. Again, move that n minus 1 to the front. And then we're going to have log of negative 32 equal to n minus 1 log of negative 2. Divide by log of negative 2 on both sides. And then we're going to eventually add 1 to that. So log of negative 32 divided by log of negative 2 . Alright, so actually if you apply this into the calculator, you're going to get an error. So what I'm going to do is backtrack a few steps, and I don't think I can erase at this point, so I'm going to have to just cross it out. So let's cross out up to here. Let's not apply log, and let me show you something. We know negative 32, if we wanted to get a common base, right, we don't have to apply log, we could just do a common base. And if we Alright, so at this point, negative 32, if I got a common base of negative 2, it's really negative 2 to the 5th, and this is already written as negative 2 to the n minus 1. At that point, if I get rid of the common base, I'll have 5 equal to n minus 1, and if I add 1, we'll get n equals 6. So that was a way around that if when you throw it into the calculator, log doesn't work so well for you. Doing it with log just makes it a little bit more of a no-brainer. However, if you throw this into the calculator because of the negatives, you're going to get an error. So don't forget, if you can't use log, go ahead and do a common base. Actually, this was a really good example to find that error. Alright, so again, if we have n equal to 6, now just apply it into the formula. So that's s sub 6 equal to a sub 1, which is negative 15, times 1 minus our rate is negative 2 to the 6th power over 1 minus, and the rate again is negative 2. So that's going to leave us with negative 15 times 1 minus, let's see, negative 2 to the 6th power. It's going to be 64 over, that's a negative and a negative, so it makes a positive, so it's going to be really 3 for the denominator. And let's see, 1 minus 64 is negative 63. If I multiply that times negative 15, we're going to get 945, and then finally if we divide by 3, s sub 6, or the sum of those 6 values, is going to be 315. Alright, so now we just need to apply the last one. Alright, so anyways, looks like I can't use the left side of the screen anymore. That's okay. I don't want to erase everything. Well, let's see. Well, I just got rid of the title. That's fine. So let's look at the last one. Again, this is, we need to use those formulas. S sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r. And then a sub n is going to equal a sub n is going to be a sub 1 times r to the n minus 1. And again, for the second one, because that's what we're looking at now, for the second one, a sub n is going to be negative 2,560 equal to a sub 1, which is 5, times the ratio. We are multiplying by negative 2 each time. So that'd be negative 2 to the n minus 1. Again, divide by 5 first. And that'll give us negative, let's see, that'll be negative 512 is equal to negative 2 to the n minus 1. Again, because of the negatives, we're not going to be able to apply log here. So we need to know a common base. So negative 2 to the n minus 1. And a common base for 512, I believe, let's see. is going to be negative 2 to the 9th power. So again, get rid of those. We're left with 9 equal to n minus 1. Add 1 on both sides, and we have n equal to 10. Alright, so then we need to go ahead and do the next one. So s sub n is really s sub 10 equal to a sub 1 is 5 times 1 minus the rate, or the ratio is negative 2 to the nth power, which is 10, we just found out, divided by 1 minus, and the ratio again is negative 2. So this is going to give us 5 times 1 minus, let's see, negative 2 to the 10th power is 1024 divided by 3. Alright, so as a final answer, we're going to get 1 minus 1024 is negative 1023. If I multiply that by 5, we'll get negative 5115. And then finally, if we divide by 3, we will get as a final answer negative 1705. And we are done. So guys, really the main thing that you need to remember, whether it's geometric series or whether it's geometric sequences, is how to apply the formula and what they stand for. If you can apply the formulas correctly, you will get the problems right every time. Alright, again, if you need any help or you need any tutoring, come see me either in the morning or after school.